Hey, it's Mrs. Weethy back for Lesson 3, Properties of Ionic Compounds. Now, ionic compounds are not formed in individual units. That is, you don't have just like one molecule like you would have one molecule of water. So sodium, for instance, doesn't combine with just one chlorine to form one molecule of sodium chloride. Instead, there are thousands of sodium ions and chlorine ions that form. And so what happens is that a certain number of sodium and chlorine ions are going to combine to form a crystalline structure. That crystalline structure is called a crystal lattice. A crystal lattice, and we can see an example here of the sodium and chlorine crystalline structure, is a three-dimensional geometric arrangement of the positive and negative particles. They're made up of repeating units, which is called a unit cell. It's the simplest unit of a crystal lattice, a unit cell. So in this crystal lattice we have here a sodium chloride table salt. You have one sodium ion. The sodium ions are in purple. One sodium ion is surrounded by 6 chlorine ions. Now we see 4 of them right here. So one chlorine ion would come out at you and the other one would go behind you. That's one unit cell. In addition, you have one chlorine ion is surrounded by 6 sodium ions. And again, you would have one sodium come out from this chlorine and one go behind it. That is also a unit cell. So these unit cells create this repeating pattern. It gives you that crystalline structure. And if you looked at an individual crystal of sodium chloride, it would have this really nice cuboidal shape to it. Every ionic compound has its own unique geometric pattern. Some other properties of ionic compounds is that they usually have very high melting points and generally very high boiling points. And that's due to the very strong attractions between the positive and negative ions. It takes a great deal of energy to melt an ionic crystal or to boil an ionic compound when it's dissolved in water. Ionic compounds will also conduct electricity, but only when it's in a molten, which is melted, or aqueous states, when it's dissolved in water. In the solid state, so if you just took it out of the bottle in the solid state, it wouldn't conduct electricity at all. And that's because in order to conduct electricity, you need freely moving negative charge. Electrolytes is a special name given to ionic compound whose aqueous solutions conducts an electrical current. Now, this is because when dissolved in water, the positive and negative ions dissociate, which means that they separate from one another, allowing for that free flow of negative charge. The question is, why? And if you don't know why, then you need to ask me about that in class. Ionic compounds are very hard, brittle, rigid solids. Now this is also due to the strong attractive forces that holds the ions in place. You need a force strong enough to break the ions apart, which will crack or separate the solids where the unit cells are incomplete. So we see here right around these edges, you have incomplete unit cells, and if you hit them with enough of a force, then you will just shatter that ionic crystal. If you take some table salt, get the back of a spoon and try crushing the table salt. You would find that it takes a great deal of effort to do that, but once you do, it crumbles into pieces. And that's the end of Lesson 3. This is Mrs. Weethy. Goodbye for now.